So in the last videos, we discussed very clearly about recursion, like applications of recursion we have seen. How many problems we solved? 3 problems. First one is how you can calculate sum of n natural numbers. How you can calculate sum of n natural numbers we have seen. How to calculate sum of n natural numbers? Whenever the value of n is equal to 0, we are returning 0. Otherwise, we are returning n plus sum of n natural numbers of n minus 1. This is nothing but how you can able to calculate sum of n natural numbers. Even we discussed one more program like how to calculate factorial of the given number. So it is the same like sum of n natural numbers, but the only problem is instead of addition, we have taken multiplication. And in the base condition, in case of sum of n natural numbers, since we are doing sum operation, whenever the number becomes 0, we return 0. But here, since it is dealing with multiplication, whenever the number will become 0, we have to return 1. How internally it is going to be evaluated, we discussed. Even we covered about one sequence like Fibonacci sequence. What is mean by Fibonacci sequence? If you take any number, it is calculated by adding previous 2 numbers sum. Example, first 2 numbers are 0 and 1. What about the next number? It is a sum of previous 2 numbers. If you take 2, it is a sum of previous 2 numbers. If you take 3, sum of previous 2 numbers. If you take 5, sum of previous 2 numbers. Like that, every number is a sum of previous 2 numbers. These are the programs what we discussed in our last class. Up to this, no doubts, right? Please confirm. Right. Now we are going to see the another program which is nothing but Fibonacci sequence. So what is mean by Fibonacci sequence? See, it is also same like Fibonacci sequence, but the only thing is nothing but first number in this sequence is 0. Second number in this sequence is nothing but 1. Third number in this sequence is nothing but 2. So first 3 numbers in this sequence are 0, 1 and then 2. Sir, how to get next number? It is a sum of previous 3 numbers. What is that sum? 0 plus 1 plus 2. Tell me what will be the next number?
3.
What is the next number?
6.
Very good. Next number?
11.
12.
Yes, 6 plus 3. 9, 10, 11. Next number?
20.
20. Like that, every number is sum of previous 3 numbers, not 2 numbers. Whatever logic we applied for Fibonacci, same logic only we have to take. But what is a sequence here? The sequence is going to change, right? This is nothing but a sequence what we have. Sir, what about the numbers? 0, 1, 2, 3, 4. Yeah, as usual, this one. Okay. Now, what is my requirement is I will change the function name as a trib. So wherever FIB is there, I am going to change it to TRIB, Fibonacci sequence. When n is equal to 0, which value we have to return? 0, right? So it is as usual n. Whenever n is equal to 1, which value we have to return? 1 only. What is another condition that we have to take for base case? Please confirm.
And all equal to 2.
Yes, if n is equal to 2, we have to return true. Sir, is there any change in this formula? What is the modification that we need to do here? Yes, what is the modification that we need to do here? Guys, please confirm. Is the formula is sufficient? So trib
N
of
minus 3.
trib of
Trib
n
of
and the Fibonacci sequence of we have to take n minus 3. That's all. Now I will run the code. So check whether we are getting first 10 Fibonacci sequence. Yes, 0, 1, 2. How we are getting these 3? By adding these 3. So we got 3, sir. By adding 1 plus 2 plus 3, we got 6. By adding 2 plus 3 plus 6, we got 11. By adding 3 plus 6 plus 11, we got 20. By adding 6 plus 11 plus 20, we got 37. By adding 11 plus 20 plus 37, we got 68. Like that, it is nothing but a sum of previous 3 numbers. Sir, if you are clear with this, I will demonstrate a tree diagram for this. Sir, clear up to this? No doubt, right? Yes, please confirm.
Yes.
So coming to this tree diagram. So first we are going to call this. Okay, first we are going to call this function. Assume I am calling for a Fibonacci of for which one I am evaluating. Let it be 4. So my expected output is a 6. I am calling for Fibonacci of 4. So how many times it is going to evaluate? 3 times it will evaluate, friends. What is the first value? So Fibonacci of 4 minus 1, which is nothing but 3. Then Fibonacci of 4 minus 2, which is nothing but 2. Next, Fibonacci of 4 minus 3, which is nothing but what? 1, sir. Like that, it is going to evaluate. Whenever t is equal to 3, again it is going to evaluate 3 times. So 3 minus 1 will become 2. 3 minus 2 will become 1. So 3 minus 3 will become 0. Whenever we are getting either 1 or 0 or 2, we have to stop. Sir, whenever n value is 2, which value it will return 2? Whenever we are getting 1, it will return 1. Whenever we are getting 0, it will return 0. 0 plus 1 plus 2. 3, right? It will return 3. What about here? It will return 2. What about here? It will return 1. So 1 plus 2, 3. 3 plus 3, 6. For this, the expected output is nothing but a 6. Is it correct? Yes. This is the way how you can able to do. Sir, clear up to this? Someone asked yesterday, sir, what is the tree diagram for this? I think now you got clarity. Am I right?
yeah.
Sir, can you explain in LIFO, sir? Once stack in stack.
Sir, it is very difficult to trace, sir. Why? Because see, even you can't understand. Because if you take here, initially we called which method? T of 4. Am I right?
Yes.
So it is divided into how many method calls? 3 times. In that first method call is nothing but what? 3. That will be expanded. This one. Okay. Again, it will be expanded with the T of 2. Then what will happen? So after this, T of 2 is returning some value. What is the value returned by this T of 2? 2. And it will add with T of 3 and it is going to return. So for T of 3, it will maintain this value. One more flow is there, right? Again, it is going to push into the stack. Like that, keep on evaluation is going on. Understood?
Okay, sir.
Yeah. So it is confusion. If you draw a stack diagram for this, it will create a confusion. That's why better to see in the form of a tree. Sir, everyone clear so that I can go for next application.
Yes.
Right. Next. So I want to demonstrate one more application of recursion. What is that application is I want to calculate number of digits, or instead of this, I will go for reverse, of the given number using recursion. Using recursion, I want to calculate reverse of the given number. Sir, how you can calculate reverse? Listen carefully. What is a function name that I'm going to take? Public static, so integer rev function, which will take a number and it should return an integer value. What is that integer value? Which is nothing but reverse. So here I am calling system.out.println of rev of 1 to 3. Like this I am taking. What is my expected output? 3 to 1. For this, we need to write logic. What is the logic? Very simple. I'm going to return n percentage 10 into, so I will typecast to integer. Which one I will typecast? There is one function with the name power, POW, which will take 10 comma length minus 1. So plus I'm going to take a recursion call, reverse of n by 10 comma length minus 1. Sir, what is this length? See, at the time of receiving the parameters, in addition to n, I'm going to receive one more parameter, is nothing but length. Sir, what is this length? How many characters are there in the number? So how many characters are there here? 3 characters. That's why I'm going to pass length value as a 3. Listen how it is going to work. So first I'm calling reverse function. By passing input as a 123, comma length is nothing but what? 3, sir. Now, what this reverse function is going to do? It is doing two activities. One is some mathematical calculation part. Another one is a reverse function calling. First, let me evaluate this. So what it is doing? It is calculating power of 10 to the power length minus 1. What is the length value that we have given? 3. 3 minus 1 means what? 2. What is a 10 square value? 100, sir. 100 is multiplied with which number? N percentage 10. N value is 123. 123 percentage 10 means we will get 3. So 3 into 100 will become 300 plus again the same reverse function we are taking by passing 123 by 10. That means we will get a 12 length minus 1. What is the previous length value? 3. 3 minus 1 means 2. Like that, just we are reducing that number. So by using some mathematical calculations. If you are clear with this, I will expand this one. Sir, everyone understood up to this?
Yes.
Is the concept is clear? The remaining people, please respond.
Sir, explain once again, sir, that formula.
I am explaining for R of 12 comma 2. You can understand. Okay. See, whenever here, what is a number, sir? Number is 12 only, right? What is a length? Length is 2. Number is nothing but a 12. In that 12, how many characters are there? I mean, how many digits are there? 2. Now, what is the formula? First, we are taking n percentage 10. Tell me what is a n percentage 10 in the second case?
2.
12 percentage 10. If you divide with 10, so 10 ones are 10. Remainder is nothing but what? 2 only, right? So 2
Yes, sir.
what is the next thing that we have? Math dot power of 10 power. So 10 power length minus 1. In the second method call, what is the length? What is the length value?
2.
So 2
Two.
minus 1 means what? 1, right? So 2 into 10 will become 20. Sir, why you are typecasting into integer means because a POW function will always return floating point value. That's why I typecasted to integer. So 2 into 10 will become 20. So first formula is nothing but a 20 plus again it will call for a reverse of what will be the next n value? Previous n value is 12. 12 by 10 means we will get 1 comma length minus 1. Previously length is 2. 2 minus 1 means we are going to get 1. Sir, understood everyone? Clear?
Yes, sir.
Yes.
Now, so again it is going to be expanded. Now you have to tell answers for this. This one is nothing but number and this one is nothing but length. Okay. So again it will calculate a formula. So what is n value? N value is 1. 1% 10. I want to divide 1 with 10. 10 zeros 0. Remainder is nothing but what? 1. So I am taking 1. 1 into. So 10 to the power length minus 1. Length value is what? 1. 1 minus 1 means 0. 10 power 0 is 1. 1 into 10 power 0 will become 1 only. So 1 plus. What is the next reverse value? So n by 10. N by 10 means we will get 0. Length by length minus 1. Length is 0. Sorry, length is 1. 1 minus 1 means 0. Sir, can I stop here whenever the value of number is 0? I'm going to return 0. So if the value of n is equal to 0, simply I'm going to return 0. That's all, sir. I hope everyone got clarity now. So it will return the value, right? So whenever the value of n is 0, it is returning 0. So 0 already 1 is there. 0 plus 1 will become 1. It will return 1. So 1 plus 20 will become 21. So 21 plus 300 will become 321. 321. Is it reverse of the given number or not? Yes. Sir, understood everyone?
Yes.
Please confirm clear
Yeah.
how it is working internally. Is it clear, right?
Yeah.
Sir, mathematics, programming, once if you see or once if you listen whenever faculty is explaining, definitely you won't get. What you need to do is you have to take multiple inputs. Okay, you have to take multiple inputs and you need to practice parallelly. That's why what is my suggestion is, so better to watch this video one more time, take some other number, okay, like maybe some 4-digit number or 5-digit number, take it in A4 paper and try to practice. Definitely, if you see the diagram clearly, then only you can understand well. So like this, you have to draw, try to draw it in landscape mode so that you can understand. Because the formula is very simple. Only thing is how it is constructed, you need to understand. Sir, clear? If I run the program, my expected output is 321. Yes, I am getting 321. This is the way, sir, how you can able to calculate reverse of the given number. Sir, if you are clear with this, I will take one more program to demonstrate. Please confirm clear up to this.
Yes.
Right. Sir, now you have to think in a logical manner because this is very, very important what I'm going to explain for a few programs. What is my next program is I want to count number of digits present in the given number. Of course, we have already some formulas are there to calculate, but I want to calculate how many digits are there in the given number by using recursion. For that, suppose if I am taking, I will define a function with name count, which will take only one parameter, which is nothing but n. So we have to run the code. So inside this, if I'm calling system.out.println of, so count of 1. Tell me what is output that I'm expecting 1. How many digits are there in that? Only 1. So if I'm passing something like a 12, what is I expected output? 2 digits are there. If I'm passing 1, 4, 5, how many digits are there? 3 digits. If I'm passing 1, 7, 8, 9, how many digits are there? 4. Suppose if I am passing 99999, how many digits are there? 5. This is my expected output. For that, we need to write code. Sir, is the concept is clear?
Yes.
So if the number is 0, how many digits are there? Simply I will return 0, sir. Otherwise, sir, 1 plus 1 plus. So can I take count of n by 10? Sir, how it is going to work? Just by taking one example, I am demonstrating. Listen. See, if number is 1789, I am calling a count function by passing 1789. Assume this is nothing but the number what I have given. So first time what will happen? Is the number is equal to 0? No, sir. 1 plus, again we are taking count of this number by 10. We will get 178, right? Yes. Now again it is going to call 1 plus, so count of 178 by 10, which will return 17. So again 1 plus, so count of 17 by 10 means we will get 1. 1 plus again we are going to get a count of 0. Sir, whenever 0 came, okay, I will return 0. Sir, 0 plus 1, 1 right, it will return 1. 1 plus 1, 2 right, it will return 2. Sir, 2 plus 1, 3 right, it will return 3. Sir, 3 plus 1, 4 right, the output what we are going to get is nothing but 4. If you want, just I will run the code, you can see. Sir, everyone understood how it is working internally? Please confirm. Just we need some logical thinking, except that nothing is required. Sir, clear? Please confirm everyone, guys.
Yes. Clear.
Understood?
Yes, sir.
Right. Now, see, I want to take one more mathematical application. What is that application? Is, sir, multiplication. Multiplication of two numbers. Multiplication of two numbers. I am going to take multiplication of two numbers. How you can able to multiply two numbers? Very simple, sir. I am going to take two numbers like this. Okay, public static integer multiplication. I will take integer a comma integer b. Listen carefully. So system dot out dot println of, I want to multiply. Okay, I want to multiply 4 comma 2, sir. Sir, if you want to multiply 4 comma 2, can I say 4 plus 4? Am I right, sir? We have to add 4 two times. Is it multiplication?
Yes.
Am I right? So, which is nothing but 4 into 2. Sir, everyone, is the concept is clear internally what is happening? 4 into 2 means 4 plus 4. Sir, 8 into 10. 8 plus 8 plus 8 plus like that. How many times you have to take? 10 times. Sir, everyone got clarity? Formula, mathematics formula. So I am applying that concept here. What is that concept is, sir, if the value of, okay, if the value of B is not equal to 0, if not equal to 0, I will write one statement. If it is equal to 0, sir, I will write return 0. Because if B value is 0, what will happen? Definitely multiplication will return 0. That is the base condition. Otherwise, what I am doing is, I am writing some small formula, friends. What is that formula? Is I will return A plus, again multiplication of A comma B minus 1 I am taking. That's all. Now see what will happen. Sir, I am calling multiplication by passing 4 comma 2. What will happen? Sir, is B is not equal to 0? Yes. Then it will return A plus, that is a 4 plus. Again, it is calling multiplication. So it won't disturb A value. B value, 1 value, it will reduce. Now what will happen? 4 plus, again multiplication of 4 comma 1 minus 1, 0. Sir, if B is not equal to 0, we need to expand. If B is equal to 0, we have to stop. What is the return value? 0. 0 plus 4, 4. What is the return value? 4. 4 plus 4, 8. Sir, everyone understood? Please confirm. Got the clarity?
Yes.
Now, sir, same example. If I want to do like this, like in the place of A value 4, I am taking 2. So here I am taking 4. What is the meaning of this? Sir, is it 2 plus 2 plus 2 plus 2? Am I right? Clear?
Yes, sir.
We have one mathematical rule. A into B is equal to B into A. Am I right?
Yes.
And if you see here, 4 into 2, how many times the recursive call is happening? Only 2 times. Am I right? But
Yes.
if you take 2 comma 4, what will happen? 2 comma 4 first time. Then, so 2 plus again 2 comma 3. So again 2 plus, so 2 comma 2. So again 2 plus, like this, we need to expand, right? Almost 4 times we have to repeat. How I can eliminate this process? Very simple, sir. I will check one more condition. If the value of A is less when compared with B, try to call return function by taking multiplication of B comma A. B comma A. Otherwise, else if you can continue. Sir, understood? First time in this case, what will happen? Sir, your A value is 2, B value is 4. Then, can you please call multiplication by passing 4 comma 2? So that it is same like this only, right? We can close with 2 iterations. Like that, just to reduce number of method calls, we are applying this process. Sir, everyone understood this point?
Sir.
Any doubt? So I want to execute and I want to show you the results. So you can see 8 and 8 we are getting. This is the way how you can able to get it. So now, sir, you have to tell what are the applications that we covered. Can you please give the names? What is the first application that we covered on recursion?
Sum of
Sum of
numbers.
n natural numbers. Am I right?
Yes.
What is the second application that we covered?
Factorial of n numbers.
Factorial of given number. Given
Yes.
number. Now, what is the next application that we have seen?
Fibonacci.
Sequence. What is the next one?
Fibonacci.
Sequence. What is the next one? Reverse of given number. Am I right?
Yes.
So next application. So counting number of digits present in the given number. What is the next application that we have seen? Multiplication. Multiplication of 2 numbers. Am I right? These
Yes.
are the basic examples what we have, sir. Okay. So next level we are going to discuss the applications which I am going to take here is x to the power y. How you can calculate by using recursion. Next and after that, very, very important, decimal to binary conversion by using recursion. Next and after that, decimal to octal conversion by using a recursion, how you can able to do. Okay. And prime number application. I want to check whether the prime number, whether the given number is a prime number or not, which is very, very important. And we need to talk about reverse of the string. At the same time, palindrome, whether the string is palindrome or not. By using recursion, I want to check. So next and after that, we have to remove, okay, we have to remove a specified character from string by using recursion. And we want to count a specified character. Okay. So in the string, these two I want to implement by using recursion. So next and after that, so sum of digits also we need to cover. Maybe I will cover here sum of digits present in the given number. Next, these are small chota applications. Next, I want to take a powerful example, sir, like towers of Hanai. So biggest approach for solving by using recursion, how you can solve. Next, we are going to see how you can able to generate possible subsets in the sense what? Suppose if you are giving a string like A, B, what are the possible subsets like A, okay, B, then AB, okay, then BA, like that. What are the possible subsets? Next, even we are going to see combinations of a string. Like if I'm giving ABC, okay, what are the possible combinations? ABC, next ACB, next BAC, next BCA, next CAB, next CBA, like combinations. Okay. Next, one small real-time application we are going to see, something like sir, keypad mobile combinations. Sir, I hope maybe whether you are used or not, so your parent can understand this one. See, there are some mobile phones are there in the olden days, keypad mobiles. Okay, so in that there will be a key called one. There is one more key called two. So there is one more key called three. Suppose on the one key there will be three characters with name ABC. For key 2, there will be a characters with name DEF. So for key 3, there will be a characters with name EFG. Like that, just assume. Sir, if I want to take, okay, if I want to print, okay, something like BAD. Tell me, sir, how you can able to press these buttons? First, which button we have to press?
One.
One.
One, two times you have to press. Am I right?
Yes.
Then
Two.
one, only one time you have to press. Am I right?
Yes.
Then two, how many times you have to press?
One.
Only
One
one.
time.
Like that we are going to get. So if you press 1, 2, 3, what possible combinations you are going to get? What is the first combination, sir? ADE. Second combination ADF. Third combination ADG. This is one combination. Then so AEE. Okay. Sorry, something here I repeated. No problem. So like this, here we have to take one character. Here we have to take one character. So three combinations. Here first character, here second character, three combinations. Sir, everyone understood the scenario, right?
Yes.
So how to do this? Seems to be the problem is very big, but nothing is there. You have to use which concept? Recursion only. If you use recursion, automatically all possible combinations you are going to get. Sir, understood?
Yes.
Right. So all these things, this cinema we are going to discuss tomorrow. So maximum tomorrow we will take some problems. Okay, maybe in this one problem I may take tomorrow, and the remaining problems we will take on Saturday. This week we have continue classes are there. Okay, this week continue classes are there. I told already, please be ready to attend the classes on weekends also. So our first weekend class will be there in this week only. Saturday and Sunday, these 2 days class will be there. So Saturday class is optional for you. Okay, maximum I will try to revise this recursion concept. Those who are not understanding this recursion, they can attend that session. Otherwise, simply you can ignore. Okay, so some important problems I may cover. Anyway, meanwhile, tomorrow try to make the payments clear by maximum tomorrow 3 o'clock. So because I am going to send a mail for you at 4 o'clock. In that mail, our regular class WhatsApp group link is there. So you are going to join into that group. So I will share the link at 4 o'clock or 5 o'clock, like that. I will share through email. Okay. At the same time, permanent class link is there. You are going to receive that link. Okay. So totally we have two links will be there for our class, sir. One is nothing but regular class link. That is nothing but 7:30 p.m. So Monday to Friday, you have to join by using that 7:30 p.m. link. Whenever I am saying there is a special class. So for that, they are going to share one more link. So you have to attend that class by using that special link. Anyway, just save that two links in your what you can call bookmark. Just save it as a bookmark. So anyway, I'm going to mention when you have to use which link. But regular link you have to use from 7:30 to 8:30 class is there, means you have to use a regular link, that is from Monday to Friday. Only on Saturday and Sunday, special link you have to use. Why? Because that link is given to multiple batches. So I'm having Java batch also. For them also, we are using the same link. Only on weekends, they will attend for extra class. If there is no class, I will post it in WhatsApp group saying there is no class. But this weekend, we have a class. The topic on this weekend is nothing but Saturday class is completely about recursion. 2 hours session will be there. Those who understood this recursion, no need to attend. Those who have not understood the recursion, you can revise the topics by attending that 2 hours session from 7 to 9. Okay. And Sunday string handling functions I am going to explain. It will be around 2.5 hours or 3 hours session will be there. Same 7 o'clock. In that I am going to explain what are the various string handling methods. So what are the SCP areas means what, heap area means what, when object will be created in which areas. And I'm going to cover 50 programs purely on strings, basics to next level. This is nothing but our agenda. So with this, I'm going to conclude the demo sessions. With this, all demos got completed. Okay. Now, if you are having any queries, you can ask me.